Chapter 10, Section 4, Other Angle Relationships in Circles. The first theorem we're going to talk about says if a tangent line and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So notice I have a circle on the screen. I'm going to draw one chord and one tangent line, and this chord and this tangent line intersect at a point on the circle. I'm going to go ahead and I'm going to label some points on this diagram. Notice that the chord and the tangent line are forming two different angles. They're forming angle ABD and angle ABC. What this theorem says is that the measure of angle ABC, the acute angle formed by the chord and the tangent line, are going to be equal to 1/2 the measure of the arc AB, which is the arc that is intercepted by that angle. If you look at the second angle that was created, the obtuse angle ABD, we can say that angle ABD is going to be 1/2 the measure of the intercepted arc AEB. Notice AEB would be the major arc here, and then arc AB would be a minor arc. An example of this theorem says line M is tangent to the circle, and then it asks us to find the measure of RST. Notice the measure of RST would be the arc intercepted by angle MRT, which is the tangent line and a secant line, and a chord, The angle of the measure of the angle is 102 degrees, which means the measure of the arc, RST, is going to be double 102, which is 204. This next example says line BC is tangent to the circle, and it asks us to find the measure of angle CBD. Notice they tell us angle CBD is 3x, and they tell us that the arc intercepted by that angle is 4x plus 50 degrees. What we need to do, and we have two different options here, but the first thing we need to do to be able to find the measure of angle CBD is we need to solve for x. If you look at this relationship, the angle 3x would be half of the measure of the arc, which we know is 4x plus 50, and then the opposite is true also. Double 3x would be equal to the arc 4x plus 50. So the first option I'm going to do is doubling my angle measure, so 2 times 3x equals the intercepted arc, which is 4x plus 50. I'm going to go ahead and I'm going to solve this for x. So I have 6x equals 4x plus 50. Subtract 4x from both sides and you get 2x equals 50. Divide by 2 on both sides and you get x equals 25. The second option that I could do is I could leave my angle measure 3x alone, and I could take half of the intercepted arc, which is 4x plus 50. Half of 4x plus 50, I'm going to divide 4x and 50 both by 2, and I get 3x equals 2x plus 25. When I subtract 2x from both sides, 3x minus 2x is just 1x equals 25. So notice it didn't matter which option I chose, either doubling the angle measure and setting it equal to the arc measure, or leaving the angle measure alone and setting it equal to 1/2 the measure of the arc. Either way, I got 25, but then we need to go back and answer the question. It asks us to find the measure of angle CBD. Well, angle CBD is 3 times x, and x is 25, so 3 times 25 is 75 degrees. The next theorem says if two chords intersect in the interior of a circle, then the measure of each angle is 1/2 the sum, the measure of the arcs intercepted by the angle and its vertical angle. A diagram of this would be having two chords, and they have to intersect in the interior of the circle. If I am going to first look at angle 1, first of all, notice angle 1 does have a vertical angle, opposite, sharing the vertice. Angle 1 is intercepting the arc AD, and the angle opposite of angle 1 is intercepting the vertical angle for angle 1 is intercepting the arc BC. So what this theorem says is to find the measure of angle 1, we would take 1/2 arc AD, which is intercepted by the angle 1, plus arc BC, which is intercepted by angle 1's vertical angle. We can also say a similar thing for angle 2, which I just labeled. Angle 2 is intercepting arc AB, and the vertical angle to angle 2 is intercepting the arc DC. So we can say angle 1, or the measure of angle 2 equals 1/2 the measure of angle AB, the measure of arc AB plus the measure of arc CD. An example of this asks us to find the value of x. Notice they've given us two chords intersecting on the interior of a circle. Angle x is intercepting the arc that measures 120 degrees, and the vertical angle to angle x is intercepting the arc ST, which is 40 degrees. So we can say x equals 1/2 the sum of 40 plus 120. 40 plus 120 is 160, and half of 160 is 80. So the measure of angle x is 80 degrees. If the measure of angle x is 80 degrees, we know that the angle opposite, or vertical, is also going to be 80 degrees. We also know that the remaining two angles are going to be congruent because they are vertical angles as well. So once we have one of the angles where the chords are intersecting, we can actually use that information to find all four of the missing angles, or all four of the angle measures on the interior of the circle. The next theorem says if a tangent and secant, two tangents or two secants, intersect on the exterior of a circle, they have to intersect on the exterior, then the measure of the angle formed is 1/2 the difference of the two intercepted arcs. A drawing of this would be having a circle. For this example, I went ahead and I have a tangent line and a secant line intersecting. Notice the tangent and secant line create an angle, and it's on the exterior of my circle. And then notice that there are two different arcs that are being intercepted here. The angle closest to the arc closest to the vertex of my angle would be WY, and then the other arc intercepted would be WZ. What this theorem says is that angle x would be equal to 1/2 the larger arc, which is WZ, minus the smaller arc, which is WY. An example of this asks us to find the value of x. Notice x is the angle created by two tangent lines intersecting on the exterior of a circle. They tell us that the smaller intercepted arc is 80 degrees, but then they do not tell us the measure of the arc RTS, which is the other intercepted arc by this angle. What I need to do to find the measure of RTS is I need to take the whole circle, 360, and subtract the arc that has been taken out of the circle by the arc RS. So I'm going to take 360 minus 80, which tells me that arc RTS is 280 degrees. To find the value of x, I'm going to take 1/2 of 280 minus 80. Well, 280 minus 80 is 200, so half of 200 is 100. So angle x is 100 degrees. Today's assignment is on page 624. It's numbers 8 through 34 all.